What's up, guys? It's Mr. Bringle, and today we're going to be talking about uh, math problems that have to do with Newton's second law. So you should have already gone over the notes for Newton's second law, but let's kind of review the equation that explains Newton's second law. Newton's second law states that a net force will cause acceleration, and so the equation for this is F equals ma. F is the force that's applied to an object, mass is the mass of the object, and the acceleration is obviously the acceleration of the object. And sometimes you'll see this equation rearranged, and I think the one that is sort of the law explains better is this one right here. So the acceleration of the object is equal to the net force that's applied to the object divided by the mass of the object. And I think that shows well, if you have a large net force, then you're going to have a large acceleration. And then if you keep the mass the same and you were to say decrease that force, let's say you had a smaller force, then the acceleration would not be as large. Okay. So let's kind of talk about units here. Force is measured in something called newtons, okay? And a newton is simply, if we think about this, right, it's mass times acceleration, right? F is equal to mass times acceleration. Well, what are the units for mass? They're kilograms. So you can see that 1 newton, which is indicated by an N, is equal to a kilogram times meter per second squared, which is the unit for acceleration. So you can see that a newton is just a simplified way of saying the units for mass times acceleration. So a kilogram times meter per second squared. So we more commonly use newtons because saying that something, I applied a force of 5 kilograms times meter per second squared isn't really practical. So let's go ahead and jump into a few practice problems here. We're going to do 3 of them together, and then you're going to have some practice problems that are on your own. So starting here with example 1, and I will leave the equations in the screen here, and I'll kind of rewrite that initial one, F equals M times A. So it says your mom pushes a 25 kilogram box with an acceleration of 2 meters per second squared. How much force does she use? As always, I would like for you to underline the things that it gives us. So it gave us 25 kilograms. Remember that kilograms are the units for mass. And it says that it has an acceleration of 2 meters per second squared, and that actually tells us what it is. It's acceleration. And then what amount of force? We're going to circle force here. So we're always going to use the guess method, and the givens here, it's given us a mass of 25 kilograms. It's given us an acceleration of 2 meters per second squared. And we know that we are solving for the force. For our units of the unknown step, I want you to rewrite that we're solving for force. And then we're going to write that the units for force are newtons, and that is a new one, so make sure that you've got that straight. The equation that we're going to use here, so all 3 of these equations up here, if I were to, number them like 1, 2, 3, it's the same equation, it's just rearranged for the different variables. So we're, of course, solving for force. So we're going to use the one that says F equals ma. Now for our first S step, which is substitute, we're going to go ahead and plug these numbers in here. So we have a mass of 25 kilograms times the acceleration of 2 meters per second squared. So we can see here when we solve for this that our force is going to be equal to 50 kilograms times meter per second squared, which is also known as a Newton. So we'll use that right there. Okay. We'll go ahead and move on to example 2. I'm going to have to clear this here, and the equations will no longer be up there for us, but I'll rewrite them. So let me go ahead and clear this, and then I'm going to rewrite the equations. F is equal to ma. You have the version acceleration is equal to force over mass. Okay. And then you've also got the version mass is equal to force divided by acceleration. Okay. So this time it says, what is the mass of a truck? So it's telling us what we're solving for right off the bat. What is the mass of a truck if it produces a force of 1,400 newtons? So there's our force right there, while accelerating at a rate of 5 meters per second squared. So there's our acceleration right there. So we'll jump into the guess method here and write down our givens. We were given a force of 1,400 newtons. We were given an acceleration of 5 meters per second squared, and then we know that we are solving for the mass. We're going to go ahead and write that out again, that our unknown is the mass and that the units for mass are kilograms. Now we will pick an equation, and it's all the same equation, but picking the correct version of it. So we are solving for mass, so we are going to use the version that's mass is equal to force divided by acceleration. The first S is the substitute step, so we'll go ahead and plug in 1,400 or 1,400 newtons divided by 5 meters per second squared. Okay, well, make sure to plug these into your calculator. Don't just write down the answer. Make sure that you do it yourself. So the mass here is equal to 280 kilograms. Okay. Now we'll go ahead and move on to our final example here, which is example 3. And again, I'm going to write those equations out for us. F is equal to ma. Acceleration is equal to force divided by mass. And mass is equal to force divided by acceleration. Okay, so it says, what is the acceleration? So solving for acceleration of a softball if it has a mass of 0.5 kilograms and hits a catcher's glove with a force of 25 newtons. So we'll go ahead and jump into it here. It's given us a mass of 0.5 kilograms. It's given us a force of 25 newtons, and we are solving for the acceleration. Now, we know that the units for acceleration are meters per second squared because we've already done that unit. So we'll write that down for our units step there. Now, for the equation, since we are solving for acceleration, we want to use the version of the equation that has acceleration is equal to force divided by mass. We'll go ahead and substitute in the givens, and we know that the force is 25 newtons, and we know that the mass is 0.5 kilograms. And so this is going to come out to be an acceleration of 50 meters per second squared. Okay. So there are 3 examples that go over how to solve for each of the variables with force, mass, and acceleration in Newton's second law equation. And you will now have some practice problems to complete on your own that are on the next page or on the other page of your notebook. So you're going to have these 4 practice problems to do on your own. Make sure to ask questions if you have them.